Hi, this is Michelle Cullen, and welcome to Astronomy 103A, the Jovian planets. This week we're going to talk about the gas giants. Remember the order of the planets: Jupiter, Saturn, Uranus, and Neptune by the acronym JASON. So here we have Jupiter, Saturn, Uranus, Neptune. In the next few minutes, I want to cover a comparison of the Jovian planets, especially looking at the composition of the inside, looking at the atmospheric conditions and the weather, and then finally a brief look at the magnetosphere, which is the source of the aurora. One interesting fact is that these are very far away and that their distance in astronomical units almost doubles with every increasing planet. So we have Jupiter that is 5 AUs, or the distance from the Earth to the Sun. Then we double that to get Saturn at 10 AUs, almost double that again for Uranus, and then finally Neptune doesn't quite follow the pattern. It would have been 40, but it's 30 AUs away. Is that they have much lower densities and they rotate extremely fast. Jupiter in 10 hours to make one rotation of this giant planet. To learn more about each planet, I encourage you to go to the solarsystem.nasa.gov and you can scroll down on planets and pick any planet you want. You can see here that 11 Earths fit across the clouded disk, and can see the giant red spot, which is a storm that's been going for over 100 years. And here you can see it in infrared and how fast it spins. In just about 10 hours, it can make one rotation. Looking at the interior, we can see that there's dense clouds here, a cloudy atmospheric that never hit a solid surface. They just eventually become more and more dense till at some point they warm up and maybe become sort of a liquid hydrogen and then a metallic hydrogen, and we're thinking that there's a rocky dense core. So Jupiter is actually more than twice as massive as all the other planets combined, which is very, very interesting. It's almost on its way to becoming a star. If it would have had a little bit more mass, it would have been able to ignite all of the hydrogen and helium. It is also the third brightest object in the sky, and that's why the ancient astronomers gave it the title Jupiter, which is just another word for Zeus too. So this is the king of the planets. In this image taken by the Cassini spacecraft of 2000, you can see that these swirling stripes and bands are the weather, and they're in bands similar to going in different directions, just the way that we have winds going on Earth. These are convection currents in the atmosphere that form these different belts and zones. We call the darker ones belts, and they're going in an opposite direction as the zones. And it's exactly the same as weather on Earth. You'll get in the tropics and the equator, you'll get warming air rising, and then it will reach the cooler area, cool and come down. And because of the Coriolis effect of the planet spinning, they'll actually go in different directions. So Pioneer 10 and 11 were the very first interplanetary spacecraft to leave Earth and head off to take close-up images of Jupiter and Saturn. So the Voyager spacecraft 1 and 2 that were launched in 1977 were also valuable sources of information for Jupiter and Saturn, but they were the first spacecraft to go to the outer planets of Uranus and Neptune. So you should know that about those spacecraft. Here we're moving on to Saturn, the jewel of the solar system. It is known as Saturn, the god of agriculture, and Saturn was father of Jupiter, Zeus. So the one that's farther is the father. And the word Saturn is also the root of the word Saturday in English. Saturn's orbit is almost spherical. It's also inclined about 27 degrees from vertical. You can see here that makes it possible during different times of its rotation around the sun to see that rings, its beautiful rings, at a better angle. It has seasons just like the Earth due to that 27-degree tilt. Saturn is made up of mostly gas, hydrogen, helium, and methane, a lot like Jupiter. And it does have clouds and stripes for the same reason of those different convection clouds and bands rising and sinking. And but it's a lot harder to see the clouds and the weather because they're mostly yellow and white. They're not as clear as. So one scientist compared them to a lemon meringue pie, and so a person who would be dropping through the icy clouds would eventually be crushed by the kind of pressure. It's fluffy and light, but it could kill you because the gases get so compressed that they become liquid eventually. And the pressure is astronomical. And of course, we'll learn more about the rings next week. They're actually just billions of rock and ice, and they're very, very thin, 50 meters thin. Here's a beautiful composite image of Saturn taken from the Hubble Space Telescope over the period of 1996 to 2000. And you can see how it travels. You can sometimes see the rings a little bit more edge on, and as it travels around the sun with that tilt, we get a view of the bands. Here's another beautiful image of Saturn from space.com. Beautiful image by the Cassini spacecraft taken in 2006. When we look at the interior of Saturn, it is very similar to Jupiter. One exception is that it has less mass and is less dense. So Saturn is the planet that would float. It has the same sorts of hydrogen and helium in the outer atmosphere. As the pressure builds up, we get this metallic hydrogen, and then finally a rocky, icy core. We're on to Uranus, or Uranus, and it is known as a sideways planet. You can see here that this is the equator as it's tipped at a very strange, almost 90-degree angle as it rotates around, making for some very extreme seasons. This icy, windy blue planet comes in third in size for the solar system. Let's see. It was found with the aid of the telescope, first by William Herschel in 1781. He tried to unsuccessfully name it after King George III, Georgium. As a German astronomer, he probably didn't think about how most people pronounce the name as Uranus, and the unfortunate consequence of this laughed upon planet. So they decided to stick with the mythology name. Uranus was the ancient Greek deity of the heavens, and being the furthest out planet that it was as discovered, they named it for the earliest supreme god. This interior composition of Uranus, we'll see that Uranus is very similar to Neptune. It is one of two icy giants in the outer solar system, and it's made up of icier fluids, water, methane, and ammonia, which are also known as hydrogen compounds. So when you hear the word hydrogen compounds, think of water. H2O has hydrogen, and methane and ammonia are also hydrogen. And it's a little different because it has a smaller rocky core, has a little bit of metal in it. The rocks have an iron nickel rock. It's interesting to note that it doesn't get its blue color from water like Earth does, but it gets it from the methane gas in the atmosphere. And what's happening is, like anything that causes a blue color, all of the light of the sun comes into it, and all of the other colors besides blue are absorbed, and only blue escapes out. It is similar, though, to Jupiter, that it doesn't have a true surface. Its planet's mostly swirling fluids, so a spacecraft wouldn't have any place to land on Uranus. It would just go right through the atmosphere until it would get into this liquid, icy liquid, and then pressurized that it would destroy a metal spacecraft. Here's another picture of Uranus, and it just has a much thinner atmosphere. So here you can see the seasons on Uranus last about 42 years because it takes a long time for it to go around the sun. Here you can see that it's hitting the sun edge on the equator, but as it continues to spin around, the sun is coming in and hitting the northern summer solstice, so everything on this side of the planet would be considered the north summer, and then you come around here, we've got the spring equinox, and that is where we're hitting the sun's hitting the equator. And then over here, it's getting all the sun over here on the southern part. So we've got extreme seasons on Uranus. Well, we're on to our last planet, Neptune. And Neptune, it was in Roman mythology named for the god of the sea, Poseidon. Neptune has a similar atmosphere and composition to Uranus. It has thin hydrogen and then a lot of methane, which helps to make it blue, and other hydrogen compounds. And Neptune is the planet that has the most strong and rapid winds in the solar system. They get these huge storms. You can see a storm here, and it can reach 2,000 kilometers an hour. Neptune is so far away, it was too far to be seen with a regular telescope. It was the first planet to be discovered through mathematical predictions, as they knew there was something that was very massive that was influencing the orbits of the other planets nearby, and they discovered where it should be through math. It was a French mathematician, Urbain Joseph Leverrier, who got the position in mass, and then when they finally got telescope pointed just in the right direction, they found it in 1846. Now, an interesting segue into the last part I'm going to talk about, the magnetosphere, is that Neptune has a magnetic field that is not lined up with its regular pull of rotation. It is tilted, and so it makes the aurora come at a really interesting angle. Turns out that it's 60 degrees from the axis of rotation, and because of the rotation and the magnetosphere, you get these aurora that go through all sorts of wild variations. It turns out the magnetic field of Neptune is about 27 more times powerful than Earth, and that leads me right into talking about magnetosphere, just if you assume that most things about Neptune are similar to Uranus for the composition and the interior and the atmosphere. Here's an image of the flux lines that are due to the magnetosphere. The magnetic core that's inside of this, each of these 4 planets, similar to that of Earth, but Jupiter has the strongest magnetosphere in the whole solar system, and that's mostly because it has so much hydrogen that's become metallic. So this is the solar wind coming from the sun and hits the flux lines coming, and they'll actually turn and they'll travel around and come back up, forming northern lights. So this is a summary of all you need to know about the Jovian planets, or at least a foundation for it. I hope you enjoyed this, and good luck filling out your reflective journal. Make sure you take time to reflect on what you're learning about and look at other sources in the internet and in your texts if you have them, and enjoy learning about these incredible planets.